Our next speaker is Dr. Karen Schwean Lardner, and the title of her talk is Broilers and Blue Light. Should you change to improve welfare, to improve productivity? Karen?
Thank you very much for the invitation. And before I start, I would like to thank Shauna for the invitation to come speak here today. So Shauna asked me to talk about some of our previous work, which focused on the effect of wavelength on commercial broiler production. But on top of the productivity, we also wanted to look at bird welfare. Some previous research has really focused on the positive effects that blue light has on productivity parameters as well as welfare parameters. But I'm going to explain in a couple of spots why some of this data may not be what we think it is. I'm not sure how many of you thought, as you grew up in the poultry industry, that we use blue light to keep birds calmer because of their inability to see. But once again, I'm going to show you data that suggests that that is not the case, and that birds actually have a better ability to see under blue light.
So that's exactly what I learned. And so that's what we thought for a long time. And a lot of places have used blue light for that particular reason. I'm going to come back to that at the end of this. And now we have no ability to change slides whatsoever, Shauna. Nothing. I'm clicking on everything I can possibly click on, Greg. There we go. Okay, that one worked. Okay, if I look at the previous work that looked at light colors, lots of this started with when LED lights came on, right? We can do Christmas lights in barns and we can do all kinds of things. Some of the very early work, though, put filters over incandescent. But I want to talk about what some of that previous research said. So in terms of blue light, most of it did exactly show what I said, calming effect. Whatever the heck calming means in birds, I'm not totally sure, but a calming effect and mostly a decreased activity there. They also showed some reduction in fear levels and stress responses, where red light increases activity, increases aggression levels, and so it's used more often in reproductive flocks. In terms of health, that previous research showed no effective wavelength on mobility for birds, and red light can actually increase lameness. Interesting. For immune function, there's research that showed that blue and green lights make better immune function. Oh, but wait, it's all confusing because there's others that say, no, it's white light, and then others that say, no, it's yellow. So it's all over the place, and others that say that there's absolutely no difference. And oh my goodness, when we get to productivity, this is your part here. A lot of it shows if we use green and blue light in commercial broiler barns, we will market heavier birds, we'll have better feed efficiency, we increase satellite cells, we have higher breast muscle deposition. Rosenbaum's work fits right into here. That's what he talked about. Oh, but wait, others say, no, that's yellow light that does that. Oh, but wait, there's more that say there's absolutely no differences. So we have some really confusing information when we talk about light color in terms of broiler production. It is certainly not consistent. So let's back up a little bit, and I'm not going to try and cover all of your stuff here today. So, but wait, sometimes we think that birds visualize our systems just like we do. And so that's what we think here. But birds do not see like we do, and you're going to hear all about that. Sorry, Darren, tough it out. Try not to do this. These are the visual spectrums that we see on the left-hand side and that birds see. So what you see for us, we suck, to use your word. We suck at vision compared to what birds see. They see so much better than we do. They have different cones, turkeys more than broilers. They have oil droplets that we don't have. They have an ability, as you said, to go through the skull. So a much different perception of light than we do, especially when we get into the light colors of blue or red on that far spectrum. If you can see here, blue, they see so much better than we do. So that's interesting, and we need to remember that as we go forward. So for birds, as Dr. Kensel said, they have image-forming light through the eyes to the brain, but they have those non-visual photoreceptors through the skull into the brain and reacting like that. And just to do that very simply, that way or through the skull and activating that way. We also know that wavelengths differ in their ability to penetrate that cranial tissues more than, and long wavelengths can do that more than short wavelengths, and we see that. And we're learning that this is even different in turkeys compared to broilers. Not there yet, but we're getting a pretty good idea that it's different depending on the birds we talk about. And each of these different pathways can result in different behaviors and physiological responses. So it's interesting that we talk about using these light colors, but we have to remember they do not see like we do. They see differently and much better than we do. Light intensity. There was a question about light intensity earlier. It is so important because it drives the difference between day versus night. It drives a number of other things. And remember, those two side spectrums, the blue and the red, holy moly, that's so much brighter for birds in those spectrums than it is for us. We need to remember that. So again, the blue spectrum, the red spectrum, they see differently than we do. The result of these differences, we need to think about that. So traditionally, we've used lux or foot candles to measure light intensity. But guess what? That's based on what we see, not what birds see. So most of that previous research and those conflicts with that measured light intensity in lux or foot candles. That means if Dr. Rosenbaum provided a blue light versus a white light, that blue light was so much brighter than the white light. And as a result, those spectrums are not really the result of the spectrums necessarily, but either an interaction between light wavelength and intensity or a difference of intensity alone. That has been missed. So because that difference is there, we need to figure out a different way to do this. I am so not smart enough to do this, but other people have. And they have developed a system called corrected lux, CLUX for short. People get a joke out of that. CLUX for short, to measure this. And this is based on how birds see, not on how we see. So, sorry, it's dry American air. CLUX actually measures intensity on how birds see. That's important. And as we go forward in any welfare measures, we need to remember it's the bird that's under this circumstance, not the people. And so we need to be careful about that. So one of my PhD students did a very large study. We did numbers of measures on what happens if we use different wavelengths, but we use that CLUX. And so in this case, the light intensity, in this work, we looked at, you can see the light colors on the bottom. Holy moly. Blue rooms, green rooms, and white rooms. Our research facility is pretty cool because we have the ability, we have 9 of these individual rooms. Each one has its own controller for everything that we have, heat, environment, lighting systems. Each one has the capability of holding up to 1,000 broilers. So big numbers in each of those trials. The 3 treatments that we used that I'm going to talk about today, there were others, I'll just briefly mention them, were blue, and you can see the wavelength there, green light and white light. And green gauge lighting out of Scotland helped us to set up this experiment. So we never do an experiment once. I never trust an experiment once, so we do them twice. We used a total of over 14,000 broilers in these studies, so big numbers of birds. That is absolutely necessary with lighting work, especially when we're looking at mortality, causes of mortality, some of those other factors. It's really important that you have a big number experiment. Besides the wavelength, we have strains, 2 different strains from Avigen. This work is in conjunction with Avigen, and male and female pens based on Dr. Kunzel's talk. I'm not going to talk about those today, though. No time. So we separated our rooms into pens so that we could put the strains and genders in those pens. That's so picky, that mouse. Okay, lighting program is our traditional lighting program that I've been using in our research. We start with 23 hours and we add darkness every single day. So by day 5, we're down to 16 hours of light and 8 hours of dark. Light intensity, as I mentioned, was the same measured in CLUX. So intensity is the same across of all of these. Dawn to dusk transitions. I love dawn to dusk transitions. I know that's a whole nother talk, but they're so important. And if anybody has any discussions with commercial producers, this should be a necessary thing to help crowding in the feeders, especially in the morning and in the evening. Okay, enough of that. Let's just go to some data because it's really cool. So remember back to those original slides when they measured in intensity, they were finding differences in body weight, differences in feed intake, feed efficiency, so many other things, behaviors, stress variables. Let's look what happens when we have light intensities the same. This is flickering again, Shauna, get ready. Body weight is on this slide. You can see on the y-axis is the body weight in kilograms and the days on the bottom. So we weigh every single bird in these experiments on a number of different days. Now, body weight here doesn't look very different, but if we look very closely on day 7 and day 14, we did find a difference in body weight. But white birds were heavier. So very different than that original research that we talked about. So use of blue light did not increase body weight at any time in this experiment. And in fact, heavier weights on those birds early on in life with the white light. Sorry, day 35 is our traditional, we ship at day 35. So that's where these experiments run to. This is feed intake, no effective wavelength. This is feed efficiency, gain to feed ratio, no effective wavelength. This is mortality, no effective wavelength. Even with 14,000 birds, we cannot show a significant difference in wavelength. And if we separate those out and look at metabolic and skeletal disorders, for example, or immune function, there's nothing. There is no difference when we use these different colored bulbs. So growers call me at home and ask, should I be spending the $100,000 to change bulbs for productivity purposes in broilers? And the answer to that is no, not in terms of production. It's not showing anything. Uniformity of the flocks, not different. Scratches, not different. So if we look at a summary of that production data, we saw nothing. We saw nothing. And in fact, we had heavier body weights early in life under white light, but no benefit of using blue and no benefit of using green. And we, as you saw, we measured those every single week so that we could look at different time periods as well. And we saw no benefit of that here. We also did a number of welfare parameters. We did a crap load of work for these experiments. We did gait scoring to look at mobility in these birds. We measured foot pad dermatitis on these birds using the welfare quality score. So this is gait score. This is the percentage of birds that fall in each of the categories. The scores are on the bottom. A 0 means a normal walking bird. 5 means a broiler that can no longer stand up. No effective wavelength. Even when we put the 3s, 4s, and 5s, which some really cool work out of Europe said birds that fall in that 3, 4, and 5 are birds that are in pain from some mobility issue, no effective wavelength. So it's not benefiting there as well. This is foot pad dermatitis. The scores again, 0 is none, 4 is a significant lesion on the paw of the bird, no effective wavelength. So it's not helping there either. So again, if growers are talking about using blue light to improve mobility, improve foot pad lesions, not doing it. We looked at melatonin, and we did this by euthanizing, killing birds multiple times throughout the day to see if we could find developed rhythms for them, and then analyzing this. So the time periods are shown on this table on the far side. Blue, green, white values are here. This one was one that surprised us a little bit. We found one period in which melatonin under blue light was a little bit different. And this has been reported in other studies to have a significant decrease. But again, it may be more related to intensity or an interaction between intensity and wavelength. We really found very minimal differences here as well. Bruna also did in retina. She did in the pineal gland with the physiologists in Western College of Veterinary Medicine. Found no differences in those either. So the melatonin data did not show us anything that we wanted to do. We also put birds into functional MRI machines. We're still working on that data, process to come, but it's interesting, and we'll see whether we see anything with those fMRIs in the brain of these birds. So what does this do to affect and behavior? Again, traditionally, we thought they can't see, so they're going to be calmer. So we measured a behavior over different scan samples. I'm just showing you a bit of this. Bruna published all 4 of these manuscripts, 3 in Poultry Science, 1 in Frontiers. So all of this data is available in the last year and a half. Please look it up if you want. But one day I'm looking at it at 32 days of age. So the first line shows us the percentage of time the birds spent at the feeder. So green light birds spent the most time at the feeder. White light birds spent the least time at the feeder. But one of the older I get, the more you need to look at a big picture. No differences in body weight. So they weren't hanging out there eating, they were just hanging out there for some particular reason, but it wasn't to consume more feed. For percentage of time spent, and this is over 24 hours, percentage of time spent walking, we see white birds significantly walked more than those under green light, which significantly walked more than those under blue light. So that historical thing about calming of birds, this is likely what people are seeing. They are less active under blue light, even when intensity is balanced in these birds. They're not moving as much. Function of walking gets me from A to B, but it also helps with muscle strength. It also helps with bone quality. But remember, there was no difference in gait score. Big picture looking and linking things together. No differences in gait score. Also, if we looked at mortality and skeletal differences, there was nothing there as well. Even with 14,000 birds, mortality showed us no differences. So the difference in walking certainly didn't turn into anything that affected mobility or bone quality in these birds. Inactivity, same thing. Blue light birds are the most inactive. They're hanging out in here. Important to remember, no differences in footpad lesions, right? When we talk about day length and long day lengths, we know those birds are inactive then as well, but they seem to be planted more at one spot on long day lengths, and we see higher footpad lesions there. Here we do not. So inactive is here, no differences in gait score, no differences in footpad lesions under these birds. Interesting. Comfort behaviors, dust bathing and foraging in this case, and it's a little bit mixed up. For dust bathing behavior, we saw the highest under white light, but for foraging, we saw the highest under blue light, partially maybe what's reflecting with those footpad lesions as well. So it's a little bit of a schmozzle. It certainly is not a clear picture. The picture we see in terms of behavior is that it does reduce activity. I'm not sure about the comfort behavior. It doesn't give us a great indication of whether this is better for this or not in terms of behavior alone. But we never look at just one thing, and we should never just focus on behavior. You need to focus on production, and you need to focus on behavior and other parameters as well. So Bruna did some tonic immobility testing. If you look at the bottom picture, this is not a bird in a coffin. This was the beautiful tonic chair that she made for them with a white satin. We howl at this picture every time we see it. So she measured tonic immobility on these broilers. She measured novel object studies. Again, don't rely on one test, use numbers of tests if you want to understand what's going on. So she used a novel object test, and that's the green light birds on the side over there. We also did responses to observer testing, where we counted the number of birds that moved as a result of somebody passing. And so 3 different fear tests to try and understand, is this like behavior where we have a little bit of a schmozzle, or is this a constant thing? So let me show you that data. This is our tonic immobility data. So this is seconds on the y-axis. Remember that higher this is, the higher the fear level is. Interesting, green and white are the same, but birds under blue light show a reduction in this. So that's one fear test. Adding over here, this is response to observer. Seconds again on the y-axis, green and white are the highest. A reduction in the second. Wow, that's 2 fear tests that show us the same information. So important. This one is the novel object test. No significant difference, but if you look at the shape of the graphs, it's the same. Wow, that gives them some pretty good ideas that blue light, when we've balanced intensity across the different rooms, when we do that, we're reducing fear levels. That's super interesting. And I thought right away, oh, if we're making them less fearful, for sure, we're going to see differences in scratches in those birds. But I showed you there was no differences. Part of that is the dawn to dusk, where we're relieving that crowding that happens at the feeder, particularly in the morning, I believe. But fear levels are lower in these birds. We did use HL ratios to look at this. We see highest HL ratios, which indicates higher stress under white light, intermediate under green, lowest under blue. Wow, that's 4 things that talk to us about fear and stress under blue light when those intensities are the same. So that's really, really interesting. And why is that happening? That's where our fMRIs come in, still working on that. So in terms of that summary, we saw some differences in activity levels, didn't relate to any production differences. We saw lower fear and stress in blue light birds. Again, it didn't relate. Big pictures. I always talk about linear additivity of stressors. 1 stress in your life is probably okay. 2, you're probably pretty good. 3, 4, 5, 6, 7, life sucks. And so by reducing stressors wherever you can, maybe that's a benefit even in commercial production systems. And using these bulbs might do that. I'm not betting my dollar on it, but Bruna also wanted to look at visual acuity, as you talked about before. So we did a number of birds, and somehow she talked people from our Royal University Hospital, which is a human hospital, to bring all their very expensive equipment to our chicken barn to look at chicken eyes. I still can't believe she was able to do this. We did a number of things, and as well the veterinary ophthalmologist. She looked at reflexes, tonometry, a whole number of different tests that we did on the eyes of these birds. We also removed eyes. When we were doing the melatonin, we collected the eyes to look at the shape of the eye. In our previous work with day length, with both broilers and turkeys, we saw that long day length makes the eyeball grow faster and bigger, although the socket doesn't change, so it changes the shape. Turkeys develop cataracts, a number of nasty things happen. So we wanted to look at these as well. Again, RUH brought out their equipment to do this. She also used spatial vision or visual acuity to look at some of the eyes as well, and developed a system in terms of some previous research where she looked at that to see if they could see differently. She analyzed it. Good enough. Okay, let's look at this. When she looked at interocular pressure under blue, green, or white light, we saw absolutely no differences. So it is not the same, it does not have the same effect as different day lengths does, certainly. When we looked at eye weight, look at those p-values. Absolutely nothing. So it is not changing the growth of the eye. And that makes sense because we showed with the melatonin that those diurnal rhythms really were not changing very much. And it is that diurnal rhythm that's really driving that big eyeball in those long day lengths. So no differences in the shape of that eye. She saw a slight difference in the equipment that the autorefractor gave us, means that they're a little bit more nearsighted than, the birds under blue light are a little bit more nearsighted than the birds under white, which is interesting because her visual acuity showed something different. This is her visual acuity data, and so those panels were various distances apart. She did this at 50 centimeters, put the bird 50 centimeters away, 75 and 100. If we look at the time to approach the correct feeder, the data under blue and white, we only tested these two, 15.8 seconds for a bird under white light to get to that feeder, half that for a bird under blue light. That's amazing. And it shows us again that that visual ability, that historical thought that they can't see is complete nonsense. They see better. They see better under blue light. The success rate at 100 centimeters, 50% of the birds found the feeder, 91% under blue light. So they have an ability to see better under that. So that historical data that talks about birds being calmer under blue light because they cannot see is not the case. And it's actually that they see better under blue light, perhaps what calms them. So the conclusions under there were they see better under blue light. So back to Shauna's original question. Should growers switch for this? Well, why might a grower switch? It lowers fear and stress level, and that in itself can improve bird welfare. We know that. Additivity of stressors on a commercial farm. I showed you in these experiments, 14,000 birds. We saw no production, we saw no mobility, we saw no differences in scratches. But for farms that have higher stress levels, maybe this is something to consider about that. Improvement in bird vision is also an improvement in bird welfare. So there are some reasons why growers might. The older I get, the more I realize if you're doing research, you need to look at a big picture and you need to look at unintended consequences. So it should be beyond what you see in your data set. The work environment, not something we studied, but I can tell you that our staff hated working in the blue light because we don't see very well. So for them to go in there every day, twice a day, at least twice a day to check birds was difficult. And a commercial barn that's much bigger could have even bigger problems doing this. So the work environment is different. Maybe it's something that we need to think about before people spend the $100,000 to switch barns. Cull birds. Try and find a cull bird in this room. We got better at it, but it is difficult. And again, if you're doing large barns, when I go work with Costco's barns in Nebraska, if you're doing large barns like this, it's very difficult to find a cull bird in here. And those culling is still what I think is probably the most important welfare thing we can do with flocks, is to cull them at an appropriate time. Change this to this blue color, not sure you're going to do that. So big pictures, unintended consequences, we shouldn't forget about this. I should also say that this system, based on this work, is being used in a number of slaughter plants in large facilities and working very well. Even in hatcheries, we're having it pop up, and hatcheries calling me to talk about blue lights there. So potentially, we can see differences in different places. But for grow-out barns, you need to think about those big consequences. Okay, expensive work. Thank you to Aviagen again, and for my Insert Discovery Grant to pay for this work. I'm going to point out quickly that in 2026, I hope you're all there, World Poultry Congress is in Toronto, Canada. Please come. Email's here. Send me questions whenever you have some. I have no idea what that took for time, Shauna, but I'm done. I talked fast because of the slide breakdown, just in case I didn't finish.
Okay, so who would like to ask the first question other than me? All right. Hi, Karen. Thank you very much. It's on. Yeah. So you talked about blue light, but can you comment at all on the use of full spectrum lighting? Because I know that's also coming up, and whether that will be beneficial, not just to choose one wavelength, but maybe go for something that covers all wavelengths that
Absolutely.
chickens see.
The question, that's Mike is hard to hear. The question over there was, what about the full spectrum where it's actually changing? And it's interesting. I don't know. I haven't seen enough data. I would not bet $1 the fact that it's going to do anything for productivity of birds, but certainly it could for comfort. It follows what we see in the natural sunlight is what most of the companies are selling. So it'll be interesting. Haven't seen a lot of data on that yet. Waiting to see that. Good question.
Thank you.
You mentioned that with blue light, there's less fear in birds. How did you measure fear in that experiment?
In those experiments, we measured it using a tonic immobility test, the freeze state. We measured it with a novel object study. We measured it with response to observer. So we used 3 separate tests. All 3 was almost identical in terms of response.
So less fear in blue light.
Less fear under blue light, apparently. And again, historically, if they used to say birds were calmer, I suspect it's the fear and the reduced activity that drove that, not the visual, not that they could not see. Dr. Hargis.
Somewhere around 1987, 1988, El Halawani and Rosenbaum, I think, were doing, is this better? Okay, I can't hear myself. They were doing studies with lighting that changed wavelength early in the day. It was started, I think, with blue and then gradually increased to the longer wavelengths.
Absolutely.
And there was an effect, and I
Yes.
think it was on pre-reproductive turkeys and then on turkey hens as well.
Yes, the Rosenbaum's work did that on turkeys, also on broilers, and they found significant impacts on both of them. What they were finding is that early in life, that blue had an impact, and then when they switched it to green, it showed a later impact. But again, when I go back to their papers, everything is measured in lux. And so it's a really hard thing to convert lux to the corrected lux, but if we attempt, we can get in the ballpark. They had a very big difference in intensity going on all over the place. So maybe there's an interaction between wavelength and intensity that we don't know yet, or maybe it was just an intensity reaction, and I don't know the answer to that, but we cannot see that. Absolutely.
Can you repeat what you said?
I will. Yes, Dr. Hargis said it was compelling and it was significant differences. They also showed differences in the number of satellite cells in the breast muscle and in the breast muscle weight for broilers when they used those different wavelengths. So we did that. I didn't have time to show you all of that data. We found absolutely nothing. In our first trial, Avagen came out and we looked for things like breast muscle myopathies. In our first trial, we found a significant reduction in woody breast under blue light. In our second trial, we found absolutely nothing, which is why we do things twice, right? Never once, because you never know. So when we match those intensities, I can't find it. 14,000 broilers and we can't find anything.
You think you're matching the intensity that was done previously, or you've changed it?
Oh, that's a very darn good
plot.
question. The question was, did we match the intensities that was done in Rosenbaum's work? I think we were close, Billy, but I don't remember exactly what they were doing. Again, I showed in that literature review, there are probably 20 studies that have measured intensity in lux, and that's why it's all over the place. And intensity itself is all over the place. That's a good question. I have to go back and look. I'm not sure.
Opportunity for meta-analysis for you.
Absolutely, more analysis.
All right, thank you. Okay, we have an online question, but we'll have Dr. Karcher first.
So my question for you is, when you look at your blue light, and you talked about dawn and dusk, could you reap the benefits of your blue light if you would use dawn and dusk to bring it up to full light for caretaking, and then go back to your blue light?
Absolutely, that's a question I get asked quite often. Yes, absolutely yes. And the more freaky a flock is, the more I would do that, right? So it may help in terms of being able to check, and that's one of the big, it might help with that. We found in some we've done so much lighting work that it gives me a headache. We found previously, if you turn lights off and on, immediately off and immediately on, especially when you're adjusting lights, so something new for them, we see a drop in feed efficiency of about 15%, whether it's leghorns, turkeys, or broilers. So anything, you saw in my lighting program here where we increase an hour a day, rather than making a big jump of 4 hours, for example, in our day length from brooding to our rearing period, we never see that drop in feed efficiency or that drop in body weight gain. So anything you can do gradually is better than abruptly for broilers and turkeys, by far. Good question.
We have an online question. Thank you for the great talk, Karen. This is Suresh from Dalhousie.
Yes.
What's your view on lighting systems for poultry floors? Should we aim for a global solution, or do we need localized zonal lighting, such as multiple colors in the same flooring, to meet the different needs of flocks or groups on the same floor?
Thank you for that question. Suresh, sorry that I didn't answer your email yesterday. I'll get to it when I get home tomorrow, I promise. The question is whether we need one lighting program for the world, I think, and the answer to that is I don't think we do. So, for example, if a grower calls me and says, I have a high degree of skeletal issues, I'm going to tell him to put more dark in his photoperiod program. If a producer calls and says, I've got really hyperactive flocks, I might say use blue lights, and I'm going to say use a little bit less darkness. So for me, every time I make a recommendation anywhere in the world, it is more flock specific. There are minimums. So minimum of 4-hour darkness, I think, is absolutely essential, and that's we're seeing in more and more places. I think in our Canadian codes of practice, we may see that actually move up to 6 hours of darkness. Good on me. So it changes slightly in different things. And so I hope that answers this question, and I will answer your email.
Hello.
Hi.
Hear me? Hi. Great talk. I have a couple questions. One is related to the HADO 1 meter that you used, because I've used that previously, and I'm just curious if there's other important measures besides wavelength and intensity, because I know the HADO meter can do quite a lot. So I'm just wondering.
Yes, the question was what the HADO meter does. The HADO meter, the Passport 1, a number of other ones. I know there's a once person here, and they're sending me another meter. There you are, sending me another meter to look at as well. It does flicker. And so we've just finished large experiments, one on leghorn pullets, one on commercial turkeys. Flickers, those are all published within the last couple of months. And the HADO meter will look at that flicker level. So good question.
is that something you would incorporate in blue light flicker or any of these current studies you talked about?
Is that something I'd incorporate? All comes down to replication numbers and whether you have the ability to do that, right? So lighting is best when you do it one room per, well, that's your replicate unit is room, right? It's not pen, it's not anything else. So as I said, we have 9 rooms, 9,000 broilers if we fill them to tops. Do you have space to do multiple treatments? As a student, tell me that. Would you add that onto this experiment? Sorry, this is my teaching mode.
With the number of pens and number of birds, it would make it more complex.
Remember that room is the replication unit. I have 9 of them.
Okay, so probably not then.
You don't have to answer that. Yes, it would be tough. It would be multiple experiments to try and do this over time. Something that's interesting. And if you have more rooms, that would be great, but they're expensive. Good question. I loved it. Sorry to put you on the spot. She's driving me to the airport tomorrow morning. I probably shouldn't have done that.
Really cool. I was really intrigued by the melatonin data, actually. And so if I understand that slide correctly, you saw the differences in melatonin at 5 a.m. and the lights came on at 6 a.m.
Yeah.
And you measured that, it was around day 18. So you were in that, or right next to that zone where you saw the body weight differences.
Yeah.
And the blue light had the lowest levels of melatonin, right? Okay, cool. So what I immediately thought of, melatonin secretion in diurnal animals, it gets entrained to that lights off, right? So it will actually start coming up right before the lights turn off.
Yes.
And I'm wondering if the blue light, at least at that age, wasn't able to entrain the brain to allow that to happen. Because that melatonin secretion at night is directly related to growth hormone secretion.
Absolutely, absolutely. So in our work with day length, I'm sorry I keep flipping back to that. In our work with day length, with both turkeys and broilers, we saw that that entrainment is so strong, right? That's why you never, never, never make a change to a lighting program in the night period. It's always in the morning because you want them to be entrained. You want them to get that feed intake an hour or so before the lights come on. And so we saw that beautiful entrainment happening. It peaks about midway night period and then starts to come back down again. So we saw that in the day length. Not near as clear with this wavelength, not near as clear, but it's very possible. Absolutely. I think Bruna mentioned a similar thought in one of her papers. Yeah, good question.
All right, I've got a question that's burning. So it's very interesting blue light results. So birds can see more nearsightedly if they're under blue light. They're more nearsighted.
That's what the refractory data showed, but I don't know what nearsighted is for a chicken. How far can a chicken see? So there's so much. I can't wait for Darren's talk because there's so much that I don't know yet about vision. Do you know the answer to that? How far can a chicken see? Okay, we're gonna talk about it. Yet at the 100-centimeter distance, they had no problem. They were twice as good at finding the feeder as the birds under white light.
So that's super interesting. And then the other question I have about blue light is about, you're saying that they were more fearful, right?
Less fearful under blue light.
Less fearful under blue light?
Considerably.
So we use blue, or the industry uses blue or green or red sometimes at shackling to calm birds or during catching. Would you suggest blue over the other colors?
Yes, that's what I mentioned at the end, and a number of plants are using that. So the new maple leaf plant, some of the Costco plant in Nebraska is using blue light, particularly in lairage. Shackling, you need to be kept big picture. It's darn hard to see under blue light, right? So you have to be careful that the forklift driver in the lairage doesn't drive over the neighbor, or that when you're shackling, you don't miss the shackles. You have to look at big pictures. But it is being used to calm birds in those facilities, yes.
Yeah, that's kind of what I was getting at, is that people need to be able
People
to
need
see
to
the
be able
birds
to
when they're
see.
working with
Big
it. That's
pictures,
huge.
unintended consequences. We have to think about those.
All right. we got-
Brian,
Oh, yeah. Nope. Hear you unless you speak into the mic.
So following up on that blue light question and lairage, if they're calmer, does that imply that they will not load as well? Turkeys. where we walk them to the loader. If we have blue lights in the pen, are we going to make it harder to move that flock down the, they'll be calmer.
So no, back up. A turkey is not a broiler. That's the other thing I say a million times. A turkey is not a broiler is not a turkey. So we funded an experiment to look at this under blue light to see if we have the same effect. We're not done. That work will be done. The second flock will come in February, will be done by summertime next year. In our first flock, we are finding very different results with turkeys. So do not buy blue bulbs for your Cargill flocks just yet. Dr. Fraley is trying to help us with some very abnormal behaviors we're finding under blue lights with turkeys. It's a different ballgame. I would love to come back and I will tell you maybe at our next Cargill meeting. So don't do it. Not yet.
All right, do we have any other questions from the audience? Online? We have one question. We have an online though. Yeah.
We have a question from Ayula. Do you think using different light wavelengths or other color could have similar results?
Do I think that other wavelengths could give us, well, we did the green and blue. We're not really interested in red light to increase reproductive performance in broiler flocks, right? So I think that we've tested many of those. The fact is, once we balance that intensity, we're not seeing those differences, right? And so I think we're in there. We know that red light increases aggression in birds. That's on the other end of the spectrum. So there's never too much research to look at something, but I'm pretty happy with where we are at. Yes, question.
Thank you for the talking. I have a question. I don't know if it's possible to evaluate in layers this kind of blue light, because I used to work with layers and we work with, especially in breeding, we work with white light. I don't know if there is a chance to use this blue light, especially that reduce the stress of the birds.
That's a very good question. Two-part answer to that question. First part answer, we are halfway through. We are just about finished an experiment looking at the effects of blue and green and white light on leghorn pullets. So far, we're seeing a little bit less aggression under blue light in those leghorn pullets. We're not done. I haven't seen the analysis of most of that other data. In terms of leghorns, I certainly don't have the facility to do that because you need those individual rooms. Dr. Fraley is helping me with a large grant where we'll put up a brand new lay facility, which will have individual rooms to be able to do that. So at some point we will be, but I don't know at this point anybody who's doing a whole lot of that. Guelph has done some work, oh, Rosie just left. Guelph has done some work on using red light in layer pullets. So if you look up Gregory Betacarrots, you'll find some of that data.
Thank you so much.
All right, thank you. Let's thank Karen Schwean
Thanks,
Lardner.
everybody.
Very good, very interesting. Thanks for leaving time for some great questions.